Hey everybody, John here. We are just going to talk about the double angle and half angle formulas today. And just like last time, we are going to derive these formulas from the sum formulas for sine, cosine, and tangent, which came directly from the difference formula for cosine. We proved those last time, but we're going to use these to prove the double angle formulas. So we're going to start with that. So if we start with the double angle or the sum formula for sine, so there's the sum formula for sine. If we let x equal u and x equal v, then we get sine of x plus x, which is also known as sine of 2x. And that gives me sine of x cosine of x plus cosine of x sine of x, which when we add together just gives me 2 sine x cosine x. So here's one of my formulas. That's the double angle formula for sine. Let's do tangent next. We're going to do the same thing. For tan of u plus v, we normally get tan u plus tan v over 1 minus tan u tan v. If we substitute in x for u and x for v, we get tan of 2x, which is a double angle. So that gives us tan of x plus tan of x over 1 minus tan of x, which is 2 tan of x over 1 minus tan squared of x. So that's double angle formula for tangent. And finally, cosine, the most useful one, because the difference formula for cosine is what is the basis of all of this. So when we do cosine of u plus v, that gave us cosine u cosine v minus sine u sine v. So when we substitute in x for u and v, we get cosine of 2x, which is the double angle formula. And that gives us cosine x minus sine x, which is cosine squared x minus sine squared x. So this is one version of the double angle formula for cosine. But then I can go ahead and substitute in 1 minus sine squared x for cosine squared x using the Pythagorean identities. And when I do that, I get 1 minus sine squared x minus another sine squared x. So this is what cosine squared became. And that gives me 1 minus 2 sine squared x. So this is another version of the cosine double angle formula. And yet there's a third version, because I can replace sine squared x with 1 minus cosine squared x. And when I do that, cosine of 2x gives me 2 cosine squared x minus 1. So we have 3 different versions for cosine of the double angle formula, and we're going to choose the one that works best for us. If we only have sines in our problem, then we're going to use this second formula. If we only have cosines, then we're going to use this formula. If we have sines and cosines, then we might use this formula up here. But all in all, these are the double angle formulas for sine, tangent, and cosine. So let's go ahead and apply this. We have cosine of theta is -3/5. We know that theta is in the second quadrant, which makes cosine negative. It also makes sine positive. It makes tangent negative. So something to consider here. But if theta is in the second quadrant, then twice theta is either going to be in the second or either the third or the fourth quadrant, right? So we have to be careful about the signs that we use. But what we're going to do is first we're going to find sine of 2 theta. And we're going to use the double angle formula for that. Sine of 2 theta is 2 sine theta cosine theta. And I know that if cosine theta is -3/5, so this part's going to be -3/5, that means that x is equal to -3 and r is equal to 5, which means that y is equal to 4, because I'm in the second quadrant, so y is going to be positive. So that means that sine of theta is equal to 4/5. And when I multiply by 2, I end up with -24/25. So that's sine of 2 theta. Now let's figure out cosine of 2 theta. Well, I can use a double angle formula for cosine. And the double angle formula for cosine, the one I want to use just has a cosine in it because that's what I was given to start with. So the double angle formula for cosine that only has cosine in it is 2 cosine squared x minus 1. And I was told that cosine, sorry, I put an x here, but we should really have a theta here. I was told that cosine of theta is -3/5. When I square that, I get 9/25 times 2 gives me 18/25 minus 25/25 gives me -7/25. So cosine of 2 theta is equal to -7/25. And now let's find tangent of 2 theta. So again, we found the double angle formula for tangent is 2 tan of x over 1 minus tan squared of x. And again, we already found what x and y were over here. So tangent is just y over x, so that's -4/3. So that's going to be 2 times -4/3 over 1 minus -4/3 squared. And I did it again. I apologize for that. These should be thetas. And so this is -8/3 over, so this is 16/9. So 9/9 minus 16/9 is going to be -7/9. This 9 is going to become a 3. It's going to cancel with this 3 here. So that 3 is going to go up to the numerator. And I have 24/7. So tan of 2 theta is equal to 24/7. So clearly we're in the third quadrant here because tangent is positive, cosine is negative, and sine is negative. So that means tangent should be positive, which it came out to be positive here. So I will see you in the next video, and we will do another example using the double angle formula for one of these functions.